The U.S. Navy's super stealth destroyer is almost ready for battle. The Navy's new first-of-its-kind, high-tech stealthy destroyer, armed with the most lethal weapons ever engineered onto a surface ship, is now beginning what's called ship activation, a process of integrating the major systems and technologies on the ship leading up to an eventual of-fire exercise of its guns and missiles. As part of this process, the Navy will eventually fire long-range precision guns and missiles from its lethal, stealthy new destroyer, in anticipation of its ultimate deployment on the open seas, service and industry officials explained. The new destroyer, called the USS Zumwalt, is a 610-foot land and surface warfare attack ship designed with a stealthy, wave-piercing tumble-home hull. Raytheon has been chosen to begin mission systems testing, engineering services and ship activation duties in support of the Navy's Zumwalt-class destroyer program. The deal, which could reach $500 million, will include production, integration and testing on the ship, a Pentagon announcement said. This work corresponds to the ongoing work of the Navy and Raytheon on the Zumwalt next-generation computer systems and blade servers being tested aboard the ship. The new system, called Total Ship Computing Environment, has had a number of software releases, with the 8th upgrade being integrated this year, Captain Kevin Smith, DDG 1000 Program Manager, explained at the Navy League's annual Sea Airspace Exhibition at National Harbor, MD. On Friday, May 20th, 2016, the new ship was formally delivered to the Navy at Bath Iron Works in Portland, Maine. The ship was formally commissioned in October of last year. The shape of the superstructure and the arrangement of its antennas significantly reduced radar cross-section, making the ship less visible to enemy radar at sea, a Navy statement said. The U.S. Navy accepted delivery of the most technically complex and advanced warship the world has ever seen, Rear ADM. Select James Downey, DDG 1000 Program Manager, said in a written statement last year. Several reports have indicated that ships off the coast of Maine recently thought the DDG 1000 was a small fishing boat due to its stealthy design. That is precisely the intent of the ship. It seeks to penetrate enemy areas, deliver lethal attack while remaining undetected by enemy radar. The ship is engineered for both land attack and open water surface warfare, Navy officials explained. In the next phase, the Navy will be driving, connecting, integrating and improving the functionality of the ship systems such as the radar, sonar and gun. The Navy will test out the basics, make sure the ship can work, then by testing those components of the ship that actually make it a warship, Wade Woodson, DDG 1000 Program Manager, Raytheon, told Scout Warrior in an interview last year. The Navy will be making sure that the propulsion system works to create the power to drive the ship at the speeds it is supposed to go. Ship delivery follows extensive tests, trials and demonstrations of the ship's hull, mechanical, and electrical systems including the ship's boat handling, anchor and mooring systems, as well as major demonstrations of the damage control, ballasting, navigation and communication systems, Navy officials said. DDG 1000 weapons. The ship is engineered to fire Tomahawk missiles as well as torpedoes, evolved Sea Sparrow missile and a range of standard missiles such as the SM-2, SM-3 and SM-6. The ship also fires vertical launch anti-submarine rockets, or SROCs. SROCs are 16 feet long with a 14-inch diameter. A rocket delivers the torpedo at very high speeds to a specific point in the water, at which point it turns on its sensors and searches for an enemy submarine. The first weapons to fire from the Mk-57 vertical launch tubes will be the ship defensive weapons called the Evolved Sea Sparrow missile and the Standard Missile-2, or SM-2. The ship is also built with Mk-57 vertical launch tubes which are engineered into the hull near the perimeter of the ship. Called Peripheral Vertical Launch System, the tubes are integrated with the hull around the ship's periphery in order to ensure that weapons can keep firing in the event of damage. Instead of having all of the launch tubes in succession or near one another, the DDG-1000 has spread them out in order to mitigate risk in the event attack, developers said. In total, there are 80 launch tubes built into the hull of the DDG-1000. The peripheral vertical launch system involves a collaborative effort between Raytheon and BAE Systems. Also, the launchers are especially designed with software such that it can accommodate a wide range of weapons. The launchers can house one SM-2, SM-3 or SM-6, ASROCs and up to 4 ESSMs due to the missile's smaller diameter, Knudsen added. It has a common launcher too. You can change the adapter or computer function which connects the ship to the missile, he said. The ship also has a 155mm long-range, precision-capable gun called the Advanced Gun System made by BAE Systems. The weapon can, among other things, fire ammunition called the Long-Range Land Attack Projectile which can strike target at ranges out to 64 nautical miles. Most deck-mounted 5-inch guns currently on Navy ships are limited to firing roughly 8 to 10 miles at targets within the horizon or what's called line of sight. The Advanced Gun System, however, fires GPS-guided precision 155 meters rounds beyond the horizon at targets more than 3 times that distance. New sonar, power systems, radar technology. The DDG-1000 is unique in that it uses what's called a dual-band sonar system. This includes both medium and high-frequency sonar designed to detect both submarines as well as mines and incoming enemy fire. Most ships have only longer range, lower frequency medium frequency sonar which provides an ability to detect submarines at long distances. Higher frequency brings a much more precise degree of detection, Knudsen explained. Sonar works by sending out an acoustic ping and then analyzing the return signal to process information through a receiver designed to help determine the shape, distance, speed and dimensions of an object or threat. High frequency is better for detecting small objects. If you are only going after submarines, then medium frequency would be sufficient. You are going to find the submarine, then you would be able to fire one of the vertically launched ASROCs to engage that target, Knudsen said. What makes this unique is that high-frequency enable mine detection and mine avoidance, he added. It makes sense that the DDG-1000 would be engineered to detect mines because the destroyer is, in part, being developed for land attack missions, an activity likely to bring the vessel closer to shore than previous destroyers might be prepared to sail. The ship is engineered with a more shallow draft to better enable it to operate in shallower waters than most deep-water ships. It has a dome that is transparent to those acoustic waves. The acoustic signal detects sea life in submarines and then sends the signal back to the receiver which processes the information. Inside the bulb, ceramic tiles transmit the acoustic wave out through the water, Knudsen said. The Navy continues to update the USS Zumwalt's total ship computing environment, meaning that the software and blade servers manage not just the weapons systems on the ship but also handle the radar and fire control software and various logistical items such as water, fuel, oil and power for the ship, Raytheon officials said. The blade servers run 7 million lines of code, officials explained. Many of the blade servers and other technical items are housed in structures called electronic modular enclosures, or EMs. There are 16 EMs built on each ship, each with more than 235 electronics cabinets. The structures are designed to safeguard much of the core electronics for the ship. Additionally, as a survivability-enhancing measure, the total ship computing environment also ensures additional layers or redundancy to ensure that messages and information can be delivered across the ship in the event of attack, Raytheon officials said. Many of the blade servers and other technical items are housed in structures called electronic modular enclosures, or EMs. There are 16 EMs built on each ship, each with more than 235 electronics cabinets. The structures are designed to safeguard much of the core electronics for the ship. The ship's integrated power system, which includes its electric propulsion, helps generate up to 78 megawatts of onboard electrical power, something seen as key to the future when it comes to ship technologies and the application of anticipated future weapons systems such as laser weapons and rail guns. The ship's electric drive uses two main turbine generations with two auxiliary turbine generators which power up to 35 megawatt advanced induction motors, Knudsen explained. The induction motors drive the propellers, Knudsen added. The speed of the propellers is run through the total computing environment as part of the ship's controls. The DDG-1000 also has an InSpy-3 X-band multifunction radar which is described as volume search capable, meaning it can detect threats at higher volumes than other comparable radar systems, Raytheon officials added. The volume search capability, which can be added through software upgrades, enables the radar to detect a wider range of missile flight profiles, he added. The ship will employ active and passive sensors along with its multifunction radar capable of conducting area-air surveillance, including overland, throughout the extremely difficult and cluttered sea-land interface, Navy officials said. Not only does the ship have a new electric drive system for propulsion as opposed to diesel or steam, but the ship is configured with sonar, sensors, electronics, computing technology and weapons systems that have not previously been engineered into a Navy destroyer or comparable ship, said Knudsen. The Zumwalt-class destroyers will have unprecedented mine-detecting sonar technologies for destroyers through utilization of what is called an Integrated Undersea Warfare System, or IUW. IUW is a dual-band sonar technology that uses both medium and high-frequency detection, Knudsen added. Medium-frequency sonar is engineered to detect ships and submarines, and high-frequency sonar adds the ability to avoid sea mines, he added. The DDG-1000 is designed to detect mines because the destroyer is, in part, being developed for land attack missions, an activity likely to bring the vessel closer to shore than previous destroyers might be prepared to sail. The ship has a shallow draft to enable it to operate closer to shore than most deep-water ships. As the first Zumwalt-class destroyer gets ready for service, construction of the second is already underway. The DDG-1001 is already more than 75% complete and fabrication of DDG-1002 is already underway, Navy officials said.